So, okay, कहाँ गया इसका एक पेन? We will continue to first. एक मिनट यार, पेन कहीं गया इसका? पेन का अरे नहीं, नहीं। ओह, ओके, तो मैं शेयर करता हूँ ये स्क्रीन. Let me first admit these two. I share the whiteboard. चलो जल्दी. And we start the next thing. So we thought, okay, so lines of so here हमने किया था. नेक्स्ट चीज है कि put differential equation of the lines of curvature. It would be the same as differential equation of the principal directions. So वो हम लिखेंगे. Okay, so let me write it down first. Now differential equation, because it's a family of curves, lines of curvature. So as last time we saw that we can write a family of curves as what do you call, as in terms of a differential equation. The solution to that differential equation would be that family of curves. ये chat क्या आ गया? हाँ, वो मैंने किया उनको एडमिट. Lines of curvature are by definition those curves on the surface such that a tangent at any point lies in the direction of the principal directions at that point. So उनकी differential equation same होगी, क्योंकि differential equation is about the direction of the tangents. Now since the direction of the line of curvature at any point is along principal directions at that point, principal directions at that point, the differential equation of the lines of directions, the differential equation of the lines of curvatures curvatures is given by the same यानी En minus FL times du square plus En minus GL times du dv plus Fn minus Gn times dv square c. अब इसको ऑब्वियसली याद रखना थोड़ा सा मुश्किल है और उसको बहुत बार यूज करेंगे, पर इसका एक बड़ा सिंपल तरीका है याद रखने का. यू टेक द डिटर्मिनेंट डी v square minus du dv and du square, और यहाँ लिखना है सिंपली EFG, फर्स्ट फंडामेंटल मैग्नीट्यूड्स EFG, और यहाँ पे L L. ये डिटर्मिनेंट अगर पुट करेंगे 0 तो विल गेट दिस डिफरेंशियल इक्वेशन. So then you could have a particular case, right, of differential equation. Now, for a Monges form, where a surface view here z is equal to f of xy, then we know that we can choose x and y as parameters. So, okay, now differential lines of curvature, we want to show differential equation of the lines of curvature. Curvature at a point on the surface, and the surface is formally z is equal to f of x y, जिसको हमें पता है, हम कहते हैं Monges form. You can not always do it, but in case we have such an equation, now we know that we can take u equal to x, v equal to y, so that du is equal to dx and dy, sorry, dv is equal to dy. Also, हमने evaluate किया है e is equal to 1 plus p square, f is equal to pq, and ये हमने इससे पहले किया है, easy to prove. And of course, L is equal to R by H, M is equal to S by H, and N is equal to T by H. तो तुम्हें पता है what is P? P is del Z by del X या del F by del X, because Z is equal to F of X, Y. इसी तरह से Q है अपना del Z by del Y, R है del 2Z by del X square, S है del 2Z by del X del Y, and T है, ये तुम्हें पता ही है, del 2Z by del Y square. So ये मतलब we have done that. So अगर मैं इसको substitute करूं, so if we substitute that into this one, so अगर मैं one में इसको substitute करूंगा, now substituting in one, substituting in one, I will get the differential equation as S into 1 plus p square minus rbq whole multiplied by dx square plus t into 1 plus p square minus r into 1 plus q square into dx dy plus t into pq minus s into 1 minus q square, or it should be 1 plus, I think, 1 plus q square, whole multiplied by dy square. This thing is equal to 0. This would be for Monges form. इसको भी ऐसे याद रखना मुश्किल है, लेकिन अगर हम डिटर्मिनेंट्स में लें तो वो इजी हो जाते हैं. और in the determinant form it would be as usual dy square minus dxy, और पहले रो में आएगा ये, सॉरी यहाँ x square है, then यहाँ पे e, that is this thing, 1 plus p square pq, और of course 1 plus q square, और यहाँ पे rst is equal to 0. अगर हम इसको इवेलुएट करेंगे तो वही मिलेगा हमें. Okay, now the question is, when can we take lines of curvatures as parametric curves, and what should be the condition we can choose them as our parametric curves? So उसके लिए हम छोटा सा theorem करेंगे. Again, it's not that difficult. ये है कि the necessary and sufficient condition, the necessary and sufficient condition for the lines of curvature, for the lines of curvature To be parametric curves, is f equal to 0 and m equal to 0. अगर ये दोनों 0 है, we can choose them to be parametric curves. Let's prove it. Now let the equation of the surface be as usual. जो हम लेते हैं R is equal to RHUV. The differential equation of the lines of curvature we know. The differential equation of the lines of curvature हमें पता है क्या है, is EM minus FL times du square plus En minus GL dV square plus Fn minus Gm dV square is equal to 0. Okay, and of course you know where of course E, F, G are first order fundamental magnitudes. Let's call this equation 1 first. Fundamental magnitudes at a point, and L, M, N are second order fundamental magnitudes. Okay. Now if the lines of curvature are taken as parametric curves, then automatically f is equal to 0. Because since the principal directions are orthogonal, तो उनका जो अगर उनको parametric curves मानेंगे तो वो parametric curves फिर orthogonal हो जाएंगी, which means f is equal to 0. Since principal directions are orthogonal. Also, since u is equal to constant and v is equal to constant are parametric curves, then therefore differential equation of the parametric curves और the parametric curves हो जाएगी du dv is equal to 0, right? क्योंकि अगर हम किसी parametric curve पे है, v curve पे है तो du 0 है और u curve पे है तो dv 0 है, तो in any case इसका प्रोडक्ट हमेशा 0 होगा अगर हम किसी डिफरेंशियल इक्वेशन पे है, और मतलब this is the differential equation of the parametric curve. Hence if lines of curvature are parametric curves, one and two must be same. They must be equivalent. They must represent the same family of curves. So which implies that अगर मैं अब यहाँ जाऊँ कि वन क्या था, टू क्या था, मुझे सॉरी यहाँ डी भी है, मैंने गलत लिखा. ओके, तो हमने देखा इसका मतलब ये 0 होना चाहिए, ये 0 होना चाहिए और ये 1 होना चाहिए, तभी ये मैच अप होंगी फर्स्ट एंड सेकंड. So that would give me, so I must have, क्या होना चाहिए, so I must have E, अरे यार चलो मैं ई एम माइनस एम क्या है, ई एम minus fl is equal to 0. Then I have en minus gl must be equal to 1. And I have got okay fn minus gm should be also equal to 0. लेकिन अगर मैं इनको पैरामीट्रिक कर्व्स मानता हूं तो f तो in any case 0 होना चाहिए. So that would mean f अगर 0 कर देते हैं तो इसका मतलब f 0 है यानी em must to be equal to 0. और यहाँ पे en minus gl must be equal to 1 and gm must be equal to 0 क्योंकि f already 0 है, which implies that अगर हम किसी का भी ना लें तो m must be equal to 0. Why? क्योंकि ना ही e 0 हो सकता है for a regular surface, ना ही g हो सकता है 0 for a regular surface. So therefore m must be equal to 0. तो f तो because orthogonality f0 होगा ही अगर हम lines of curvature लेंगे. और अगर इस इन दोनों इक्वेशंस को मैचअप करेंगे तो m वुड बी 0. सो इन एनी केस f एंड m मस्ट बी 0 अगर हम पैरामीट्रिक कर्व्स को लाइंस ऑफ कर्वेचर लें. Okay, now conversely, suppose that f is equal to 0 and m is equal to 0. Then equation 1 becomes, मैं दिखाना है वो पैरामीट्रिक कर्व्स बन जाएंगे. इक्वेशन 1 अगर ओके अब f0 है m0 है तो ये टर्म पूरी की पूरी 0, f0 है m0 है तो जैसा कि हम एक्सपेक्ट करते हैं तो अगर ये दोनों 0 हैं तो 1 would become en minus gl into du dv is equal to 0. So but en minus gl cannot be equal to 0. Why? Because otherwise the point would be an oblique, indeterminate हो जाएगा, इसका कोई मतलब नहीं रहेगा. Because otherwise the point would be an oblique point. Hence du dv is equal to 0, which is the differential equation of the parametric curves. So for our lines of curvature becoming parametric curves, so we must have for a surface f0 and m0. Okay. Now, regarding the same thing, basically the relationship between principal directions and the difference. What is the? अब हमें पता है कि kn जो है वो है our normal curvature at a point. So kn, as you know, is L du square plus twice m du dv plus n dv square divided by e du square plus twice f du dv plus g dv square, right? And this in fact is equal to r double dash dot surface normal. So ये अपना normal curvature है और इसी का least and highest value at a point is k sub and k sub p, and they are both connected by what we call Euler's theorem, which हम करेंगे next. So Euler's theorem. तो ये कहते हैं नॉर्मल कर्वेचर, इसकी जो स्टेटमेंट है k sub n in any direction can be expressed as k sub n is equal to k sub a cos square psi plus k sub b sine square psi, where Ka and K sub p are principal curvatures at that point, and psi is the angle which the direction of the normal section, which the direction, let's call that du dv of the normal section in जिसका curvature k है, makes with one of the makes with the principal direction dv equal to 0, यानी v is equal to constant. तो इसका मतलब इन वे हमने लाइंस ऑफ कर्वेचर्स को, क्योंकि हम इसको एक प्रिंसिपल डायरेक्शन मान रहे हैं, सो वी हैव चूजन आवर लाइन डायरेक्शन टू बी पैरामीट्रिक कर्व्स. तो सो बेसिकली उसी से हम ये डिराइव करेंगे. सो लेट्स do the proof. So let the equation of the surface be as usual. R is equal to R at UV. If the lines of curvature are taken as parametric curves, then, as we know from previous theorem, f is equal to 0 and m must also be equal to 0. And normal curvature becomes Kn would be equal to L du square plus twice m du dv plus n dv square divided by e du square plus twice f du dv plus g dv square becomes, and it would be equal to, अब क्योंकि f0 है m0 है तो मिडिल टर्म चली जाएंगी, so it would be L du square plus n dv square divided by e du square plus g dv square. So let's call this, नाम देते हैं इसको, let's call this, okay, the principal curvature k sub a being the normal curvature of the direction, अब चूंकि लाइन ऑफ कर्वेचर जो है वो है अपनी पैरामीट्रिक कर्व्स, for the direction dv equal to 0 in a u curve, so k sub a would be ऊपर वाले में डाल दो dv को 0, so it would be L by E. It's just L by E क्योंकि du cancel होगा. And similarly k sub b would be, of course, n by g, क्योंकि du by it would be in the direction du is equal to 0 because I'm taking my lines of curvature to be parametric curves. Now considering a normal section in a general direction, now considering a normal section of the surface in the direction du dv, that makes an angle psi with the principal direction. dv equal to 0, the angle between them would be what? So it would be cos of psi is equal to, okay, so it's like a situation like this. I have a curve, another curve, which are mutually orthogonal. ये बनी नहीं, चलो मैं ऐसे करता हूँ, इसको जरा ऐसे करते हैं, यानी यहाँ पे जो टेंजेंट्स हैं वो आपस में ऑर्थोगोनल हैं. ये है मेरा v इक्वल टू कांस्टेंट यानी t, u इज इक्वल टू 0 वाली डायरेक्शन ये है t, v इक्वल टू 0 वाली डायरेक्शन, और ये है अपनी du dv वाली डायरेक्शन ऑन सरफेस. इसको काटते हैं और u कर्व के साथ यानी dv इक्वल टू 0 वाली डायरेक्शन के साथ, तो ये du इज इक्वल टू 0 यहाँ ठीक से लिखता हूँ मैं. सो इसके साथ u कर्व के साथ इसका एंगल साई है. सो so you just take du equal to 0. Just a minute. तो हमें पता है जो हमने किया था इससे पहले, the expression for angle between two directions, उससे हमें मिलेगा this must be equal to 1 by root e into du by ds plus f into dv by ds. So it is generally the expression for the angle, but since I am taking dv equal to 0 वाली direction, so it is just root e into du by ds. And of course sin psi उसी फॉर्मूला से होगा h by root e into dv by ds. But we know that h जो है वो है eg minus f square, और चूंकि f 0 है, I have chosen my parametric curves to be lines of curvature, so it means this is equal to g, so it is basically eg divided by root e into dv by ds. That would be, of course, it would be, नहीं sorry, h square इसके बराबर होता है, so h is equal to root of this thing, so root e cancels, so it should be, चलो मैं यहाँ रब करता हूँ. Okay, this should be just root g into dv by ds. अभी तक मैंने इक्वेशंस का नाम दिया था, let's call this second and third. Okay, so that जो kn है मेरा, kn is equal to L du square plus m dv square by e du square plus g dv square, but this is equal to L हमें पता है du square plus m dv square, और चूंकि ये metric है, this is the same thing as ds square, so it would be L into du by ds square plus m into dv by ds square. So that would be okay. Now using, हमने लिया था क्या था वो, k sub e और k sub b के लिए वैल्यूज कहाँ थे वो, कहाँ गया अपना k sub a is l by e, so e k sub a into du by ds का स्क्वायर प्लस, अगर मैं ये वाली इक्वेशन यूज करूँ, n by g, so k, so n is equal to, आ गया मेरा l था और m नहीं n है, सॉरी, क्योंकि m तो 0 है, n. So n can be written as g times kv. So it will be g times k sub b into dv by ds square, which can be written as k sub a into root e du by ds का स्क्वायर plus k sub p into root g into dv by ds का square, which would be using these equations by third, by second and third, that would be cosine and sine sine. Root e du by ds would be k into cos square psi plus kp into sine square psi by second and third. Okay, so that finishes our, what do you call it, Euler's theorem. अब इसकी corollary है जो कि it's not that difficult to do. Okay, let me just take the next page. Corollary. Corollary जो इसकी है, it's called two pins theorem भी इसको अलग से कहते हैं. तो अगर two pins theorem आए तो उसके लिए Euler's theorem भी तुम्हें प्रूव करना होगा क्योंकि इसी की corollary है, straight forward आ जाएगा. यानी हम कहते हैं if kn1 and k sub n2 denote normal curvatures, in any two orthogonal directions, at any point, then k sub n1 plus k sub n2 उनका जो सम होगा वो हमेशा होगा बराबर k sub a plus k sub b. प्रूफ इसका बड़ा इजी है. So we know that by Euler's theorem, from Euler's theorem, so k and sub would be equal to ka cos square psi plus kp sine square psi, where psi is the angle between the direction of the normal section what uh, with curvature k sub n1 and dv equal to 0. यानी जिस कर्वेचर का या जिस डायरेक्शन का लॉन्ग विच नॉर्मल सेक्शन का कर्वेचर के एन वन है उसके साथ जो dv इक्वल टू 0 के साथ जो एंगल बनेगा वो है साइन. So it implies that then kn2 must be equal to ka into cos square into pi by 2 plus psi plus k sub b into sine square of pi by 2 plus psi. क्यों? क्योंकि आप उसमें ऑर्थोगोनल है. अगर ये साई बनाएगी एंगल विद सर्टेन डायरेक्शन, के सब एन यू की जो डायरेक्शन है, तो क्योंकि वो म्यूचुअली ऑर्थोगोनल है वो एंगल बनाएगी पाई बाय 2 प्लस साई, which implies that k sub n2 is equal to k sub a sine square psi plus k sub b cos square psi. So just take this one, take this as 2, adding 1 and 2, you obviously get what? K sub n1 plus k sub n2 is equal to k sub a plus k sub b. So that would be our two pins theorem. So we've got around 4 minutes. Now I want to do this Rodriguez formula, which is again for the curvature of the normal section at a point. So let's do it. उसके बाद general surface of revolution. So let's continue with the Rodriguez formula. Rodriguez formula says the necessary and sufficient condition, the necessary and sufficient condition for a curve on a surface on the surface to be a line of curvature. हमने इससे पहले भी necessary and sufficient condition की थी, is k dr plus dn, of course these are vectors, is equal to 0 vector, where k denotes the normal curvature. उस पॉइंट पे जो नॉर्मल कर्वेचर है, अगर वो इसको सेटिस्फाई करता है तो वो लाइन ऑफ कर्वेचर होगी, और अगर वो उसका नॉर्मल कर्वेचर उस पॉइंट पे इस इक्वेशन को सेटिस्फाई करता है, यानी अगर वो लाइन ऑफ कर्वेचर होगी तो सेटिस्फाई करेगा, अगर सेटिस्फाई करेगी तो वो लाइन ऑफ कर्वेचर होगा, वेयर k इज द नॉर्मल कर्वेचर. इसको कभी कभी ऐसे भी लिखते हैं dn प्लस रो टाइम्स, सॉरी, dr plus rho times dn is equal to 0, where rho is equal to 1 by k. तो rho is the radius of the normal curvature. तो इस तरह से भी अगर तुम्हें एग्जाम में आए तो वो भी सही हो, because you just have to take rho equal to 1 by k. प्रूफ में थोड़ा सा हमें ज्यादा कुछ नहीं, वो डॉट प्रोडक्ट यूज करना है, वो जो हमने इससे पहले किया था. So let the curve be a line of curvature. On the surface R is equal to RHUB. पता नहीं कितना टाइम है अभी, जस्ट फिर से निकलना पड़े, अभी 1-2 मिनट है तो कर सकते हैं. Now the lines of curvature satisfy. Now the curvature of the lines of curvature, which are basically the same, इनका जो डिफरेंशियल इक्वेशन वही है जो सेटिस्फाई करेगा, क्या बोलते हैं, प्रिंसिपल डायरेक्शंस को. Lines of curvature को, just a minute. So I have, that is, now the curvature of the lines of curvature satisfies these equations. It is KE, कर्वेचर K में लिखूंगा यहाँ पे, वहां पे हमने Kn लिया था, लेकिन अब चूंकि उसको हम यहाँ K से रिप्रेजेंट करते हैं, so it be KL times lambda is equal to m minus K times F, and KF minus m times lambda is equal to n minus K times G. तो ये हमने वहां किया था जब हमने लाइंस ऑफ कर्वेचर या प्रिंसिपल डायरेक्शंस का कर्वेचर जो है, या प्रिंसिपल कर्वेचर वो उसका क्या बोलते हैं डिराइव किया था. तो वहां पे हमें एक्चुअली वहां यहाँ के एन था, लेकिन चूंकि हम यहाँ नॉर्मल कर्वेचर को के से रिप्रेजेंट करते हैं, सो डजंट मैटर, हमने सिंपली लेटर चेंज किया. सो आई थिंक मैं यहाँ बंद करता हूँ, बिकॉज इट इज लेस देन 1 मिनट, फिर तुम